Okay, so we're going to talk about building a successful hybrid and multi-cloud strategy. My name is Galen Silvestri. I'm a senior solutions engineer over at GigaSpaces, and let's dive right into it. So there we go. The increasing importance of the cloud. Not long ago, cloud computing was considered, I guess, a disruptive technology, right? It was really only embraced by innovative startups, primarily those that could afford the audacious risk to adopt new technology for mission critical operations without that disruption, right? And then today, completely different trend. Even the most traditional industries, they're migrating to the cloud. It's no longer a dirty word. Some are completely leaving their legacy systems behind, some of them, not all of them. And eventually, at some point in the near future, traditional on-prem data centers will maybe they're going to be obsolete. So let's look over at the stats for a second. Obviously, we see this projection by 2022. 75% of all the databases will in the cloud. Only about 5% of them may move back for different reasons. Over here, we have 90% of companies today are in the cloud. And if you are one of those 10%ers that are still not there, if you have a little bit of FOMO, here's a tweet that I found a little nerd humor in. This is Kelsey Highwater over at Google Platform Cloud. And he suggests if you are in that 10% you don't have in the cloud yet, maybe just pivot and start labeling your infrastructure as a pioneer in edge commuting, and you're back to the forefront of technology again. Okay, so let's talk about, I'm not telling you anything new. I'm not talking about any big surprises here, but let's talk about what drives this, the data for this transition. Every organization, they have an increasing need to easily store, access, analyze, share, secure all of their digital assets. In the cloud, it offers storage capacity, availability, scalability, agility, and it offers it at scale that would be resource and probably cost prohibitive if you were to try to do this in parallel or in an on-prem environment. So the cloud offers dramatic reduction in the overall complexity of the data and the management. It abstracts everything. You don't have to see it quite as much. And so some really simple examples, a data scientist, she may need a ton of GPU time during a training sprint when she's training a model. But as soon as that's done and she's consumed what she needs and she's met her high scale peak, she doesn't need it anymore. So you can scale down to save money, only on demand. Right. Another example may be fluctuations in demand. We obviously know things about Brexit, Black Friday, and even more relevant now is COVID and the famous like toilet paper supply chain disruptions. And how do you fix that? How do you scale up to meet that, to meet those different types of demands? A service in the cloud, it offers one click usually for a free trial. You can, where an on-premise implementation, it may take 6 weeks to set up. So there's a reason why Snowflake IPO made so many waves recently. But there are some challenges to cloud migration. Number one, technology is less in your control. You know, if you're used to be doing this on your end, you have all the control factors, you lose that a little bit. You have less of a direct connection to the underlying infrastructure. And then there's legacy infrastructure. And before I really entered this industry, I was really surprised to know that maybe 96 out of the top 100 US banks or world banks, I think, still use mainframes. That's amazing. 23 out of 25 of the major top US retailers also use mainframes, right? All of our ATMs, I think, when you slice and go to an ATM, that's 90% of the time you're hitting a mainframe in the background. So there's operational considerations, right? Mission critical, long-standing legacy structures. Do you really want to disrupt that? How do you re-provision your existing IT, retrain them, have that DevOps, and then how do you actually provide for this new type of scale up and scale down rather than a finite provisioning? And then financially, how much will you pay at the end of the month, right? You have something like Amazon Athena, which is pay as you go, pay for only the queries you run. That's great, pay per use. But budgets can be complex. And, if you were an economist and, you're from a logical perspective, I think I heard it on Freakonomics, we should only be paying for per use, per cell phone, per the minutes. That's how it was when it started out. But human behavior and all the businesses that are based off of it is not logical, and so we make mistakes. So often those budgets become different than what we're manifest as different as what we're forecasted, much like presidential polls, and so you don't necessarily know. So it's something to get a better security handle on. We talk about security, right? Obviously fraud, hackers, bad actors, we get all that. But also industries are bound by compliance. We have GDPR, PII, personal privacy information, sensitivity for data, has restrictions over different international borders. What I have in Germany, I can't necessarily share in the United States. Another example is TikTok. It's in the news right now. It's a lot of hoopla over it. How, what are they sharing? And making sure that those regulations are met. So what we're doing here in this presentation is we're proposing a hybrid approach. Hybrid cloud technologies offer more control over how and where the data is stored. So some drivers for this hybrid approach, large retail banks, retailers and banks, anywhere that the on-prem still has a large presence, right? We mentioned mainframes, but those players, they still may want to modernize and add new services while maintaining that legacy. But they just prefer, they want to make that journey to that cloud, that migration, but they want it to be slow, risk averse, and non-disruptive. And there's also the privacy compliance related issues that we talked about before. Things like call centers. If they have PII, they have restrictions and regulations about what they can put into the cloud and what they can't. Some of it they can, some of it they can't. Banks are also bound by PII regulations. CRM billing systems have to be kept on private premise and infrastructure. And yet, all of this, there's still that drive, there's still that need to say, hey, if we can get around these issues, we want to innovate, we want to move to the cloud, we want to be able to have that flexibility and that scalability and obfuscate the infrastructure when we need to. And then there's geography, right? Disaster recovery, if one location goes down for whatever reason, another part in the world still is up, high availability, shifting from different time zones. And politically, how do you remove the need for an additional full data center in another country? US-based multinational, maybe they're not willing or they can't afford or they're not able to build a whole separate data server overseas just to comply with GDPR, so maybe they don't expand. Is that expanding cost worth the juice? Is the juice worth the sweetness and the squeeze? So all these things are to consider. A couple more: acquisition, maybe say something like QVC and Home Shopping Network. They combine different disparate billing centers. Maybe one is in the cloud, maybe one's on-prem. How do you merge those together? Maybe one's on AWS, and how does that work when you're trying to bring everything together? And then there's this fear that when you do go into the AWS or do go into Google Platform or Azure, are you locked in? Are you then at their whim? Are you doing technologies that aren't necessarily open source and you can't easily move out? And then you're stuck with them. And that the cloud can be really expensive. So like, how do you use it for things like cloud bursting, right? Where companies could run their workloads on premise when they need to, but during high demand bouts like tax season or COVID disruption, suddenly or major trade stock sell off or something like that, how do they then push that extra compute scalability into the cloud, get what they need, and then bring it back down for this outburst over there? So we're going to try to address some of those questions over here. And listen, this isn't anything new. This is all coming out recently. The big three, Amazon, Google Cloud, and Azure are all embracing edge computing. So we're kind of circling back to Kelsey Hightower's tweet right? The big three, I think the first official multi-cloud platform from a mainstream public provider was Google Anthos. Anthos is powered by Kubernetes. That's that popular container as a server offering. So everything is containerized and can be orchestrated and built out. And so now these implementations, you can either push it out to a VMware, or you can push out these containers, whether you're on-prem on an edge cloud, or you're in Google Anthos, and then have everything communicate back and forth for various different needs. Right a few months after Anthos, Azure Arc came out. So you can deploy Azure services, Microsoft services anywhere, and extends that management to almost any infrastructure. And then Outpost, traditionally AWS, they were like public cloud only, that's our strategy. But then they made a strategic shift, and now popular storage features are available both on AWS cloud and also within a customer's privacy legacy data center. So customers can choose from two variants. They can choose native AWS or VM cloudware, and basically you're allowed to get S3 APIs on your own data center, on your own edge cloud. But also worth mentioning too here is IBM's acquisition and subsequent development and investment of Red Hat OpenShift. So it's another Kubernetes container platform, and it features tools to manage hybrid and multi-cloud deployments on both public and private cloud systems. But the goal here is that all of these big players, they recognize there's a need. They want to provide their customers, their enterprises, even their small organizations with a frictionless transition to the public cloud by delivering consistent experience, whether you're on-prem or in their cloud provider. But let's also talk about multi-cloud, right? Rather than just a hybrid between on-prem and cloud, let's talk also about multi-cloud. One cloud does not necessarily fit all the needs, and often companies might leverage multiple clouds with unique features. So let's also review some of these examples here, why multi-cloud might be desirable. So GCP, Google Cloud Platform, may be leveraged, I think, for analytics and machine learning, for like specifically with BigQuery. That's where they're used a lot. Then we have a customer that we'll talk about later in a case study that leverages Azure for IoT hub. So, Internet of Things, all their assets have sensors on them and beacons push back to that hub. But then what do they do with that? The analytics and everything else is preferred by their sales and marketing team in a completely different location geographically on AWS. So they have to merge those two together. And then maybe something, a simpler thing, just about UA, UX design and product design, right? Azure and AWS, they both have machine learning suites. They both have platforms for building models, training models, and then deploying them. But SageMaker for AWS, it's more of a code-heavy type of IDE, interface development environment, right? They require deeper knowledge of the data engineer. Where something like Machine Learning Studio for Azure, maybe someone even like I could, with a couple classes, could figure out their drag and drop UI and UX and build something, a rudimentary little thing. Figure out why my packages keep getting stolen off my front stairs from Amazon in Brooklyn over here. So another example, multinational organizations might consider location-based regulations. A company opening a factory in China right now is required by law to store all of its data in a Chinese cloud service provider. Alibaba gets everything. It's a free-for-all for them. Of course, we're kind of doing the same thing now with TikTok, but it's a point of contention, and there's issues about that. Then but on the U.S. side, we have the U.S. Cloud Act. So an American company may think they're safe. They're in Ireland using Google servers over there based in Ireland, and yet they are still subject to U.S. subpoenas. So there's a ton of other geographic and based regulation examples We talked about being locked in already, like due to high transfer costs or technical challenges or moving to another provider. That's just hard sometimes. So maybe if you start off right away by leveraging multiple different providers, you have more flexibility, more negotiation, and it spurs the cloud providers to innovate. So many organizations, they're working with 2 or more cloud providers. So coming up here now, let's talk about multi-cloud is great. It's great. So some of the pros we got, again, placing workloads across multiple cloud environments. You get more features. You support innovation. You're avoiding that lock-in that we talked about before. You can expand in organizational reach. Light speed is a factor at long distances, right? So for high availability, you want something close by. Years ago, even before the cloud was really starting to take off, I worked for an FX trading company, this platform, and competing banks would actually fight over where their servers were located, and they fought over whether their servers were less than or centimeters from their competitors. It was a crazy place. I mean, they also had these like keyboards that were purposely made for temper tantrums. So if you were one of the few human operators that still existed there, you had a keyboard that you could work with one hand and smoke with the other because you're just like focusing on that. And then if you got mad and you decided to have a temper tantrum and you threw the keyboard down, it'd break apart, and you could put it back together very easily. So it was a crazy time. Anyway, I digress. The point is geography factors into latency. For if you want high availability, you want to meet your SLAs, you need to be able to have some sort of data center pretty close by. And multi-clouds and hybrid clouds have a way of reducing that latency. It supports localization and optimizes adherence to regional and regulations, and improves the overall performance. So we talked about HR, also disaster recovery. If there was some political disruption, or just some, God forbid, another hurricane or something else that's going on, you can switch over easily. We talked about the best pricing. Right now, the last I checked, Amazon Blob costs significantly less than AWS 3, but maybe their services are better or well known. So you can negotiate and work around that. So at the end of the day, multi-region and multi-cloud offers more flexibility, but it also has greater complexity, right? Data replication and distribution with multiple geographic distributed active clusters to support business operations. It could be challenges in so many different cases. And so this starts into the segue of what my company has been providing this solution. An organization can benefit from a data fabric with granular selectively connects to various different clouds or on-prem implementations, and then leverages the best benefits of each of them while mitigating the drawbacks of being tied to one individually. So going in, let's talk about what the GigaSpaces, the company that I work for, in-memory data grid. We're providing a smart ODS, an operational data store, and we help mitigate multi-cloud and hybrid challenges like data locality, right? The in-memory data fabric supports collection of data and connected cars in, say, Germany. So one local data center stores all that information protected by the EU and the GDPR. And then the in-memory microservices of the data fabric of this smart ODS can push and filter out certain data, not all data, selectively in the most efficient way in compliance with all the PIA and GDPR hash. It anonymizes it, and it integrates the remainder of that into a global data fabric. And then you can update global aggregations and KPIs on the fly for actionable notifications and translytics, which are transactional-based analytics transactions that can be based on analytics that happen in the real time right away, moments later in the United States or back in Germany, as if it was the data center that was connected right near you with that locality. We talked about security already, but the idea is that we can these microservices within the data fabric provide all the encryption and security that you need for all those compliances, and they can do it at scale without performance loss. Data replication is hugely costly, right? Costs coming out of the cloud from AWS, then the network costs, and then costs going back into a cloud to Azure or to on-prem. The in-memory data fabric uses an AI oriented approach to optimize the efficiency and mitigate the amount of data needed to transfer. It smartly pushes all the data, but only the data that you need. And it's not just by filtering out like deltas, but it also looks at business logic. What do you need? And it looks at what's most often, deploying indexes maybe over the full data itself, and figuring out how to reduce the footprint all the time. So there's SLAs, high availability, disaster recovery, right? The in-memory data fabric can obfuscate multiple clusters and present it as one unified scalable API anywhere in the world that you just have access to. It provides high concurrency while still ensuring consistency. That means ACID-based for transactions, meaning that all transactions get the same queries if nothing else has been updated, and it can automatically scale up and out, meaning making the virtual machines of the containers larger or putting in more containers, more processing units, automatically scale those up to meet demand for peak things like Black Friday, again, COVID, pandemic surges, presidential elections, and then it scales back down when no one wants to look at the presidential elections anymore because they're just tired of it, right? So it goes back down and you save money that way. Okay, a couple more minutes on setting up the Insight, and then we're going to jump into what the product is itself, and then we're going to jump into a quick demo. So let's dive into some of the more mitigation, the multi-cloud challenges. GigaSpace is a modern data and analytical platform. It has been designed to help enterprise seamlessly accelerate and scale their mission-critical, sensitive applications and services. And this distributed in-memory data fabric software platform can ingest, process, and store large amounts of volume at any data type, whether it's structured, unstructured, semi-structured, and then it brings it in. The data ensures low latency across all environments, and the data fabric ensures latency all across all environments and clusters, regardless if you're on-prem or in the cloud. So it makes it easy. So here's a quick architecture just to show you where we are over here. It's a smart operational data store, or smart ODS. Some may better identify this as a digital integration hub, or DIH. You've heard of ODS before. Many organizations have an existing ODS. We bring that smart on top of it, and we'll talk about what that is. So whichever you prefer, acronym or whatever, the Insight platform, it can connect to multiple siloed operational stores, whether they're in different organizations, but also across geographic locations, as well as the systems of record, right? That primary golden source record. And they can do this all with one click, a no-code connect. I just connect to it. It automatically scans what's there, automatically creates the schemas, imports it, creates the partitions, figures out how much you need. It does that automatically for you without any code. And that's significant because it takes out human error. It takes out days of trying to figure this out. And it also, on the other end, it can also connect to BI tools with one click. So if they support JDBC connectors, they can automatically connect to this. So we can set this up in very, very quick instances. 4 weeks sometimes, 6 weeks, we can get it up and running from start to go live. It's pretty important. And then it aggregates all the data into a low latency data fabric, right? So you can get it very quickly, not just the data itself, but aggregations that are on the fly or done based on event-based architecture that are updated when the data comes in. So you can mix streaming data with long tail historical data and produce these really rich aggregations and KPIs right away for you. And so you offload API access. So from all these other different stores, they may not be scalable, they may not be operational, they may have different types of API, they may not support SQL, they may support only NoSQL or anything else, and we kind of scale all over on that, and we obfuscate it with one unified UI, so you don't have to worry about it. We do it at scale. Number two, over here, once the data is ingested, it's distributed into multiple units. Here we have hot data, which we call RAM. RAM is called hot data, rather. Then we have SSD, which we call warm data. So it's a different tier. And then we have a third tier, and maybe even a fourth tier, what we call cold data and archive data. So externally located cold data lakes or legacy ODSs or warehouses, we can move data up and down that with an AI optimized management for these tiers. So the AI manages not only the data moving up and down to figure out what's best to keep up in RAM for fastest access, SSD maybe for fast access, but a little bit less expensive, but by the way, it's persistent. And then also, do you want to move it out to the low availability archives, but then do we index it? So we can index things in higher places like RAM, you can index SSD, or SSD can index the data lakes or the ODSs, and that really includes read performance a lot quicker. So you can move those things up and down. So it's not just things like time to leave or last recently used, it's a whole bunch of different custom business factors that you can use. Like, hey, I know that I need this particular field all the time. I may not need it right now this week, so the AI might not pick it up, but I have a business rule that says I'm gonna need it come Black Friday, so let's make sure that that's in there. And so the point is that you meet it on demand with no degradation in performance. So number three, the warm data, not only costs less, but since it's persistent, we have a lot of availability with HA and DR, right? We also have GigaSpaces wide area network, which we'll get to, which talks to, so where we're looking right now is an individual processing unit. That processing unit can be sharded, meaning broken up into many, many different partitions, as many as you want to form a cluster, right? So you'd see multiple of these smart ODSs in a cluster working in tandem, but then you can have multiple clusters. A cluster could be in the cloud, it could be on-prem, it could be in different clouds, and then it can all talk together. So we have these three layers of data resiliency, right, of data recovery, the wide area network for redundancy. We have the way that the AI smartly synchronizes all the clusters, whether they're on-prem or not. We have the SSD that's persistent, so it actually allows things like Kubernetes, advanced features like self-healing containers to go back and to replicate. And then of course we have backup processing units. So you have a primary and a backup. So you have all these, and it allows us to keep up 5 nines of availability. Number four, high performance compute engine, rapid aggregations. This is important. This is why we provide the value, not that just we're up all the time. So you have custom business logic microservices, right? And this is attained by having co-location and logic in the same space in each processing unit in each container. So there's no network latency. I can make aggregations because the data is there in the same space. It's been routed according to that partition. And then on top of that, I don't have the overhead of on-heap procedures, meaning that I don't have to instantiate a Java object and all the overhead and the garbage collection that goes with that to get a property to enumerate through that thousands of those instantiated objects and then come out with an aggregation. I can just look at the aggregate property individually very, very fast. So it's extremely fast in those two ways of doing that. And then we have, because we are microservices and we have custom logic, any type of logic can be put in there, we can trigger anything. It can be maybe because a new entry was updated, or a new field, or a new column, or an entry had reached a certain threshold, or an aggregation was completed from another microservice. So you can have these string of microservices bubbling up. And then finally, we have a unified API. So primarily, we support SQL fully compliant, which means we can do multiple different types of complex queries. So it's not just one query about like from a key value pair, but we can do queries on multiple different things. So you can talk about, give me an example of a car with tires that's colored red, that's in New York, and all the cars that come up that way if we're looking at pieces of that. And that can be really important. You can do that with some of the other systems, but you end up having to duplicate the footprints and creating a primary key for each of the different types that you're doing. This, you don't have to, it's one footprint. So we're cutting everything in half or a quarter or whatever it exponentially might grow up to. We're cutting it down to one to improve the efficiency of everything going through. Okay, the GigaSpace RAM, real quickly, what we have here is a WAN, wide area network. So it's our out-of-a-box distributed cluster synchronization, or one cluster over multiple different areas to bring it back together again. So we provide data replication very efficiently from one cluster into another. It moves data between an on-premise data center and the cloud. It moves it between multiple cloud vendors, among multiple regions for a single cloud platform. If you wanted to have an Uber cluster, it's AI optimized, and it's designed to minimize the amount of data that's transferred during replication. Transfers always only the changes. So if I have maybe the number, this is probably rudimentary, but if I have a field that maybe has the number 10 and it gets updated to 20, maybe I just add that 10 on top of it. Now, obviously, right, concatenate the rest of a blob field or something like that without having to put the rest into it. And it's made, so rather than moving the entire data store, we're just doing the deltas, right? And you can filter this out on what you're on what gets moved. So you can do it by privacy, security standards, however you need. So, and then of course, we can create a hybrid cluster that would support an on-premise and a cloud over an entire, just one cluster over multiple different data centers, or regardless of whether or not it's in the cloud. And this really starts to eliminate the need for data movement in some cases. So we have a French banker, Société Générale, I think we can mention them, and this huge bank, and they have multiple different clusters. They have one in France, they have one in London, they have one in New York, they have one in Hong Kong. They abide by all the regulations, and they're able to push out their data and then have all these other applications that use it as a centralized hub, as a centralized operational data store, as if it was in their own backyard, but they're only privy to the information that they need, but it happens in almost, I think it's something like network latency plus 1 millisecond. That's how fast in many cases that we're able to get it to go. We have another customer in the United States, an industry leader in transportation. They have multiple clusters. We'll get to that later. They have one on-prem, and then one in every single cloud provider. So they actually have one in Amazon, Google Cloud, and they have one in Azure as well in the data center, and they're moving all back and forth seamlessly as we're going through. Okay, so let's talk about the network efficiency real quick. I think I have about 10 more minutes left, right, Terry, before we go into discussions. Is that about it?
About 15 minutes left, actually, or about 10 minutes left. Yeah, that's
okay. So I'll do about 10 minutes, and then we can go into QA real quickly. So network efficiency, everything is replicated exactly once, not 2 times, not 0, exactly once. Allows for deltas, aggregations that we talked about before. Transfers are faster, they tie up less bandwidth, the enterprises incur lower data transfer fees. And we can also apply, we have microservices that can apply compression, data locality, right? One-click database integration for any database, maps to the data modeling, auto-defines the data indexes and partitioning schemas right out of the box, sets up your BI tools, and then replication from one region to another is done in minutes or even seconds, as we said before, even milliseconds in some cases. It can be unidirectional or bidirectional between the data centers, and it can be very specific, like I only want to replicate this table, this column, or this threshold when it goes up. And the smart ODS unifies everything, so it's as if it was generated locally. Privacy compliance, it defines what data fields should be anonymized, encrypted, stored, and all according to custom regulations. So let's take a little bit more about those regulations. We have usually P0, P1, P2, and P3 scales, right? P0 is a data stays on-prem no matter what. You can't move it out. It's a no-no. P1, it's encrypted before it can be moved to the cloud, but you're allowed to. P2 is anonymized, meaning it can be hashed, but it can be unhashed once it's up there. And then P3 is stored in clear text. And you can mark each of these different fields, each of these different tables, each of these different thresholds, these different events, these different aggregations, all to be replicated based on these levels and what they're allowed to do, so that you have different ways of being able to see that. Now, AI-driven autonomous scaling. Right here, we actually see a UI on the right-hand side for the scaling. Perhaps you see 28 times demand increase on Friday, so you might write a business rule at a certain time period to allow for that, and then you scale down for money. So the idea is to meet peak scaling. So whether you're on-prem and you just want to use this when you're scaling outwards on the cloud for what we call cloud burst, or you are in the cloud but you want to reduce because you know you're paying a lot of money. These are ways to reduce that total cost of ownership. Use only what you need, waste not, want not type of thing. And the platform, it can also do automatic detections, right, based on CPU and RAM, but also based on anything, the number of orders, the number of trades. Okay, this number of part of these things here, this is an indicator that I'm going to suddenly need to up my my scaling to either scale up or scale down. And all this is done without any performance impact. You scale up or out, vertically, horizontal, without having to turn anything off. This happens on the fly with transparently. So you can, obviously factors if the CPU is above 80% for more than 2 minutes, or if it's below X%, then scale down. Resiliency and availability, right? We talked about bidirectional, unidirectional between the WAN. So you can have active, you can active passive deployments. You can direct users based on location and proximity or load. Disaster recovery and organization might help workloads on-prem, but a disaster recovery in the cloud or another geographic locations. And we have a feature of auto recovery, right? Not just with the Kubernetes, but also with the WAN, where we can load things back in the event of, in the unlikely event of a failure. And we've talked about cloud bursting. We can go into more detail about that later. It's not, some cases with really high intense mission critical real time, you don't need cloud bursting. But if you have a little bit of room for latency, you can really do a lot with basically leasing some compute power only when you need it. Okay, here's a quick study from one of our customers. It's a leading manufacturing industry leader, and basically they have a bunch of, they had a need for predictive maintenance, right? And so what they did was that, and they needed real time, so they had IoT sensors on all their assets, and that got replicated. Now, Azure does a really good job as an IT hub because it's uniquely done that way, the way it's designed. So it brings it all in there. However, all the way in, that's in Virginia. In Ohio, which is a little bit away, we have all of the AWS champions. And that's because the marketing and the CRM and the analysts, they all prefer to use AWS. That's just how they do it. So we were able to move the data in real time and back and forth, and bring things back and forth to actually to the Ohio data center in real time, and sometimes asynchronous. We'll talk about the different ways why we prioritize some and not others, and for the different regions. And in some cases, like I said before, we achieve network latency plus 1 millisecond. So let's go through just a couple ways of how that's done. This code here, it's just XML. And basically what we're saying here is that we can provision multiple sites in less than 10 minutes, as many sites as you want. Just adjust the simple XML. You can link clouds. So you have a sync up here that would say AWS or Azure East. And then we have maybe the delegator that we push things through later that would get through on AWS East as well. So they're going back and forth. And so, you know, Societe Generale has a setup like this. You know, and some of them they use bidirectional, some of them they use the unidirectional. But again, to move things from Paris, London, New York, and everything else going through. So the LRMI protocol, this is an industry standard and allows services that are running in the same space to share their communication resources and allow non-blocking I/O communication with minimal serialization overhead. Basically allows a lot of shared resources, but without clogging up anything, so you can talk. And so we're going to leverage that. And what we're doing here is, this is a case where we're prioritizing it. This is data that was requested right away. I need it right away. So if it's not in my local store, if it's not in Virginia, and I need it, it'll immediately go to Ohio and fetch it and bring it back synchronously. I can't say the word, but that's the word. Synchronous, very fast. I don't know why I started with that word all my life. Okay, so conversely, for low priority, let's say that you want to get the data from a remote site, but you're just anticipating that you're going to need it. The AI is going to know that you need it based on a person's profile, based on characteristics that we've used. So it's not as high of a priority right now. So we're going to do it asynchronously. I still can't say that word. Okay, so here we're going to leverage an event-driven polling container. We're going to predict when the data will be needed, and then we're going to do something with it. So the top half of this code over here, we're registering to an IoT sensor event. It can be a specific event, an operation, a read, write, update, or a specific threshold. The temperature is greater than 80%, any SQL condition. And then from that, what we do is we can then, the bottom half of the code is what happens when we have the notification. We push it out. Okay, 5 more minutes left. I'm going to do a very brief walkthrough if we have time. The idea is that I have a very rudimentary setup. I have 2 clusters. They actually only have 1 partition. Here's a screenshot of multiple partitions over here on the right-hand side that you can see, so that multiple distributed processing units, 16 units, 8 primary, then the 8 backup, and then they would talk. But this case, what we're trying to show is that I'm going to put a feeder, I'm going to update it and into 1, and it's going to be connected by the WAN, and it's going to immediately push it out to the other one from Virginia to Ohio. So let's see if I can do that real quickly. I'm going to bring up whoops, here we go. Here are the 2 entries right now. You can see here we have 18.808 and 18.808 on both sides. These are entries. If I was to click on to go to some of the object types, I have unstructured data, which has been deleted already because it had a time to leave. But I can look inside the messages and I can see these some of the data structure that's in here. If I was to do a SQL and run it, I can see the first 10 would be here. This is what it would look like, all my different entries. By the way, if I wanted to, I can also look at things about connecting a new data source. This is my one-click connecting to MySQL, Azure, or anything else. And there's other plugins that you can install in here to get whatever you want. I simply put this in here and it automatically will connect to the database look around, figure out the schema, and bring it up very, very quickly. So right now we're seeing that there's minimal RAM being used. Everything's kind of in a stasis period. Nothing's being read or anything else that's going on with it. And the same thing on this side here, it's in mirror. Now I'm going to open up a local script here in my IntelliJ, and basically I have a feeder. The feeder is using some very basic UI. First, it does a full SQL compliant message to find out what the maximum amount is, and then it's just going to add on top of that, create some messages. And then it's also going to create a document object here, right, to be able to put some different things in here. So I'm going to hit the play button, and it's going to start. It's going to connect to everything, and if the demo works well, which it doesn't always because it's a demo, we'll see what happens with it. Okay, here it is. It's immediately starting to update. You'll see on one side it's being updated, and then in a couple seconds, the other one also gets updated. So this is set with lower priority probably, and because it's not a lot of processing units, you don't get the same type of speed as something that you would see with that network latency -1 millisecond, but it does show everything. The idea is that when it stops, you're going to achieve basically available. So an individual cluster is always consistent. It's ACID compliant. And we can make WAN procedures, some of them synchronously, we can make them ACID compliant, but the transfer of data, as we're seeing in the background, and we can talk about locking and transactional things on how we can do this and optimistic locking. But the idea is that at the end of the day, it's going to connect up here, and I can monitor, and then I can see not only has the data been placed in here, but then also I've created that other data types in here too, right? So that I'm able to see all the different types of objects, including this unstructured data, that if I was to read this now and look through, it has these document objects in here that I can query, even though they're document and they're imported as NoSQL, I can query them as if they were SQL to bring them in. And then run this, and eventually it'll be completely consistent going through with everything. So I think that really concludes the demo. We can just, in the interest of time, I'm going to try to move this back to my other window here. How do I do that? I'm still learning Mac. Okay, here we are. So this is my wrap-up slide. The future is both cloudy and bright. So I'm really bad at predictions. I'm freaked out about the US elections. Don't know what's going to happen just yet. So I definitely can't even tell you next week. I can't tell you what's going on in 2021. But I can tell you as far as next week that it's going to maybe be sunny at some point. Actually, I don't know. It's been really rainy as I'm looking at my window here in Brooklyn. So I'm kind of bad about that. But I can tell you that digital transformation requirements are pushing more industries to migrate to hybrid, private, and public infrastructures. And these industries are finding the need to leverage real-time insights and large assets stored at disparate sources across multiple geographic locations in a unified way. I want to look at it. I just want to know that when I request the data, it's there. I don't need to know what's all the ugly and the sausage making that's underneath. Just give it to me. So this layer on top brings that that speed, but also not just caching it, but smartly replicating it, smartly preparing it for use, smartly pushing it across the different data centers. All this is obfuscated. It makes it easy so that you can do implementations that maybe would take months, 6 months. You can do it in a couple of weeks because you don't have to worry about all the infrastructure needs. You just worry about your business logic. And so thanks to a true cloud-native in-memory data fabric, these enterprises are now proving able to transition from legacy systems to a modern infrastructure, and they do it with minimal risk at the journey speed that they feel comfortable with. And they're enabled to support growing volumes of data without having to increase mainframes or infrastructure, and their increased number of queries, and they're achieving more speed than ever before. They're doing this at scale, availability, and high service levels. And so all this is done with our smart ODS smart operational data store offering from GigaSpace. That's it for me. Again, Galen Silvestri. Feel free to send me any questions, and I appreciate your time and listening to me. Thank you.